When solving an equation that requires factoring, there's two important things to remember. First, the equation must be set equal to 0. Without this step, the method that you're using does not work. Once you get the equation set equal to 0, then you can factor the other side of the equation. So we want one side of the equation to say equals 0, and the other side of the equation is going to be some polynomial that you can use one of your factoring methods to factor. Let's do some examples. Let's take the equation 6a squared equals 2 minus a. And let's solve this. When you see that you have a variable taken to the second power, one of the methods that you can use to solve this equation is to solve by factoring. So what I want to do first is to get one whole side of my equation to be 0. So I've decided to take this 6a squared and subtract it. If I subtract it from both sides of my equation, 6a squared minus 6a squared gets me the 0 that I'm looking for on one side. Now I could have chosen to move the 2 and the minus a to the other side as well. Now when I bring them over here, I'm going to go ahead and write these in order. I'm going to put my squared term first, and then my term without the square, and then my term without the variable. Because I know in a minute what I'm going to have to do is to factor this trinomial. And the method that I was using to factor trinomials was to put them in order and find the two terms that I need to rewrite as my coefficients for my middle term. So I'm going to identify my a, my b, and my c. So in this problem, a is the -6, b is -1, and c is 2. So I'm looking for two numbers that multiply together to give me a times c, which is -6 times 2, or -12. But I'm looking for them to add together to give me a -1, which is b. So two numbers that multiply together to give me -12, but add together to give me -1. Well, things that give me 12 would be 1 times 12, 2 times 6, and 3 times 4. But in order for that to be a -12, one of the two numbers in the pair would have to be negative. In order for them to add together to be a -1, I want the two numbers to be only one different. So this is the pair that I'm looking for. And I would need the 4 to be the one that's negative, because 3 times -4 would multiply together to give me -12. 3 plus a -4 adds together to give me the -1 that I'm looking for. So now I'm going to rewrite my middle term. So I'll have -6a squared plus 3a minus 4a plus 2. Taking out what they have in common, let's take out a -3a. That'll leave me with 2a minus 1. Take out a -2 over here to get the 2a minus 1. So now I factored this. I originally started with 0 equals -6a squared minus a plus 2. But I was able to factor that side of the equation to be 2a minus 1 minus 3a minus 2. Now, this would be a good place to stop your solving and just check that you factor this correctly. Because for some reason, if you made a mistake in your factoring problem, you would not be able to get the equation solved correctly. So what we would want to do is to multiply these two terms times those two terms and make sure that they actually did multiply together to give me that trinomial. So if you've checked your factoring and you're sure that it's correct, what we're ready to do now is to use the equations by factoring idea that this factor times this factor would have to multiply together to give me 0. Well, we know enough about multiplication by 0 to know that the only way that that could happen is if one of these factors had a value of 0 or both factors had a value of 0. So what we want to do is figure out, when do each of these factors equal 0? When does 2a minus 1 equal 0? And when does a negative 3a minus 2 equal 0? So what I've done is I've written two small equations that I can solve, and the answers to those equations will be then the answers to the solutions to my equation. So we add 1 to both sides here. 2a equals 1. Divide by 2. So a could be 1/2. That's a possible solution to this equation. Solving this other equation, let's add 2 to both sides. So a negative 3a equals 2. Divide by that negative 3. And a could be a negative 2/3. I found two possible solutions to my equation. A could be 1/2, or a could be a negative 2/3. Just like other equations that you've solved, you can check these solutions. You can take the 1/2 and go back to the very original equation and replace a everywhere you see it in the equation with the 1/2, and check that your right side and left side of your equations actually do equal each other. And then you could go back and do the same thing with the negative 2/3. Put it back in the original equation everywhere you see the variable and work it out to make sure that negative 2/3 actually does make your equation true. Let's look at one more example of an equation that you could solve by factoring. This time it's going to look a little more complicated. Let's take x minus 1 in parentheses times x minus 9 in parentheses plus 2 equals negative 5. Now we know that solving equations by factoring only works if we can get one side of our equation to equal 0. So let's take this over here, this 5, and add 5 to both sides, because a negative 5 plus 5 will give me a 0 on that side. But now I have this messy left side of my equation, x minus 1 times x minus 9. I can go ahead and take my 2 plus 5 since they're like terms. Now since I got one side of my equation to be 0, I know the next thing that I want to do is to factor the left side. But that doesn't look like anything I can identify as a factoring problem. So what I need to do next is to go ahead and multiply this part out and figure out what x minus 1 times x minus 9 actually is, and then see if I can combine the 7 so that I can get something on this side that looks like a polynomial that I know how to factor. If you multiply this out, you get x squared minus 9x minus x plus 9 and the plus 7. Combining terms there, then I'm going to actually end up with x squared minus 10x plus 16 equals 0. Now I have a polynomial that looks like something we know how to factor. If you go through all of the steps to factor that polynomial, you'll end up with the factoring problem x minus 2 times x minus 8 equals 0. So now we can look at, when does x minus 2 give me 0? And when does x minus 8 give me 0? So we solved those two mini equations there to find the two solutions to my problem. This one is true when x is 2, and this one is true when x is 8. So I have two solutions that I can go back to my very original equation and check.